Hi there, welcome to another video for ordinary level Leaving Cert Maths. We're going to continue today with patterns and now look at arithmetic series. So up until this point we've been looking at sequences, which were lists of numbers. A series is where we add all the numbers in the sequence together. So we're summing them all up as we go. Our sequence was 1, 3, 5, 7, 9. The series then will be 1 plus 3 plus 5 plus 7 plus 9. So the only difference is we're adding them all together. Tn was the nth term of a sequence. So T1 was the first term and T8 was the 8th term. To differentiate between a sequence and a series, instead of using Tn, we use Sn. So the sum of the first n terms in the series. S3 will be term 1 plus term 2 plus term 3. So if you're talking about S, you're going to be series, you're going to be adding them all together. If you're talking about T, it's just a specific number in the sequence. We have another formula for the sum of a series, so that makes our life a lot easier. And it's on page 22 of the log tables, and the formula is Sn equals n over 2 times 2a plus n minus 1 times d. Quite similar to our previous formula. And as you can see here, highlighted, it says Sn is the sum of the first n terms, where a is the first term, d is the common difference, and then it gives you the formula. We'll be using our a and d just as we were with the sequences. And let's look at an example. So find S20 of the series 5 plus 8 plus 11 plus 14, and it continues on. So S20 means the sum of the first 20 terms, and Sn equals n over 2 times 2a plus n minus 1 times d. That's our formula. First things first, you need to write out what your different pieces of information for the sequence are. A, the first term in this sequence, is 5. D, the difference between each of the terms, is 3. And n, the number of terms we want to add, well, we're looking for S20, so we're looking for the first 20 terms. And now we fill in to our formula. So Sn, we're looking for S20 now, so we replace it with S20. N over 2 becomes 20 over 2 times 2a. A is the first term in the sequence, which is 5, plus n, which is 20, minus 1 times d, the difference, which is 3. This can go into the calculator, but I'll do it out by hand for this one as an example. Okay, so the sum of the first 20 terms is 670. Example 2. Given the series 5 plus 7 plus 9, if n equals 192, find the value of n. Again, you want to write out your formula for your series. And now we're told that Sn is going to equal 192. Using the information we're told in the sequence, A, the first term, is going to be 5, and D, the difference, is going to be 2. And now we'll fill in what we know, and we're going to then solve for n. So we do not know n, so it stays as n, but we can replace A with 5, and we can replace D with 2. And then that is all going to be equal to 192. And what we get here is a quadratic equation. So if I bring everything over to one side, I can rewrite it as n squared plus 4n minus 192 equals 0. And you remember from quadratic equations, it's the factors of the constant, so factors of 192, that will add to plus 4, the middle number. Okay, and then looking at these, we can see that 12 times 16 gives 192, and the difference between 12 and 16 is 4. So if I had 16 take away 12, it'll give me 4. So I'm going to have a positive 16 and a negative 12. And I replace the positive 4n in my formula with this. So I have n squared plus 16n minus 12n minus 192 equals 0. Take out the highest common factor out of the first two and the last two. So n bracket n plus 16 minus 12 can come out of the next two, and we're left with n plus 16 equal to 0. So one of my factors is going to be n plus 16, and my second factor is going to be n minus 12, because that's the common factors that we took out, equal to 0. We need to solve for n. So we let the first factor, n plus 16, equal 0. Well, n then equals negative 16. Or it could be the other factor, n negative 12 equals 0, so n equals positive 12. And if we think about our pattern, which one of these makes sense? Well, you can't have the negative 16th term, so that one is incorrect. So n must equal 12. The 12th term of the series, when you add up all the terms, will give you 192. The third example, the final one. In an arithmetic series, Sn equals n squared plus 2n. Find S1, the first sum, S2, the sum of the first two terms, and S3, the sum of the first three terms. And hence write down term 1, the first number, term 2, the second number, and term 3, the third number. So S1 is going to be where we replace all the n's with 1. So it becomes 1 squared plus 2 times 1. 1 squared is 1 plus 2 is 3. So the sum of the first one number is 3, so term 1 is going to be 3. S2 is where we replace all the n's with a 2. 2 squared is 4, plus 4 is 8, so the sum of the first two numbers is 8. So if we go 8, take away 3, we're left with 5, so the second term in the series must be 5. And then S3 is where we replace all the n's with 3. 3 times 3 squared is 9, plus 6 is 15. So the sum of the first three terms is 15. So if I go 15, take away 8, it gives me 7. So term 3 must be 7. So our sequence goes 3, 5, 7. And it continues on then. That was the sum of an arithmetic series. I hope you found that useful.